Section 17. We'll go over worksheet 3. Did we go over number 6 yesterday with power rule? No, okay. So I don't go through the steps here. Make sure you guys don't have any questions here. So this is number 6 on page 38. It says find the general antiderivative. So I'm just going to put the integral notation around my terms. And as I do that, I'm also going to clean up my terms to get it ready for power rule, because we know that if we want to do power rule, each of our terms have to be sitting, each of variables have to be in the numerator. We can't have radicals, and parentheses has to be taken care of. So first two terms are ready to go. The third term, I can pull that root x up as x to the negative 1/2. And I can push the 1/2 out as a coefficient. And then the x cubed, I can push that up as x to the negative 3. Okay, so now every term is ready for power rule. We can now apply power rule. So we add 1 to the exponent, divide it by that same exponent. Okay, what does pi become?
Oh, yeah.
Pi x, right? It doesn't become pi squared over 2. It's not power rule. We don't treat pi like a variable, so we don't do this, right? Okay, we add 1 to the exponent, keep that 1/2 in front. Keep the 1/3 in front, add 1 to the exponent. Careful, this doesn't become x to the negative 4, right? We're adding 1, so negative 3 plus 1 is negative 2. Now we're just multiplying and cleaning up. Dividing by 1/2 is the same thing as multiplying by 2. 1/2 times 2, which has become 1. I can cancel the 5s out. This becomes 1/6, negative 1/6. And I'm going to push that x to negative 2 down. I have my answer. I just want to resolve any negative exponents. So yeah,
I didn't take off credit if we don't show like one step like that first.
That's fine. You don't have to show every step. I just want to be convinced though that
Yeah.
you know that you oh, this integral notation. Yes, yeah. I want to see the integral notation to indicate that you are about to take the antiderivative and then take the antiderivative. Any questions with 6? Okay, number 7, we want to find the antiderivative. We want to find the integral of dx. So let's go ahead and write that notation. Okay, so I want to encourage you guys to memorize or rememorize your derivative trig rules, right? You can write those down at the top of your quiz page, and you just have to, using it as a reference, you're going to read your integral rules from right to left. So these are your, so as a reminder, right? These are your 6 trig derivative rules. Sine is cosine, cosine is negative sine, tangent is secant squared, cotangent is negative cosecant squared. secant is secant u tangent u, and cosecant is negative cosecant u cotangent u. So if I want to find out the integral of negative 2 cosine, I'm going to find cosine that shows up on the right side and see where that leads me. So what's the antiderivative of cosine? Sine. So that means I'm not going to change the negative there. That negative is going to stay. I'm just going to make this negative 2 sine. Does that make sense? Right. So if you're doing antiderivative, you're going to find the rule on the right and make it move to the left. Okay, what's the antiderivative of sine? Negative cosine, right? We know that sine, negative sine will take me to cosine, but if I want to do integral of sine, the negative has to move over to the other side. And then what's the integral of cosecant cotangent? Negative, right? Negative cosecant. Now that's going to force that negative to change signs. So plus 5 cosecant. Don't forget plus c. Okay, so if we know our 6 trig derivative rules, these should not feel like new rules. You're just having to adapt and move the other direction to get to your integral rules. Okay, number 8, find the most general expression. So we're going to take the antiderivative twice because we have to make our way from second derivative up to f of x. So I'm going to show the integral notation. First, I'm going to find f prime. F prime is the antiderivative. So the integral notation to show what what action I'm about to take, and then I'll take that action now with power rule. Plus what? C, yeah, C sub 1, that's right. You can do C sub 1, or you can do plus C and then make the second one plus K. It's up to you. Let's do some cleanup before we move on to the next step. So right, so now that I have my expression nice and clean, I'm going to indicate what I'm about to do to get to f of x. I'm going to take the antiderivative of this expression, and then I'm going to apply power rule again. So we apply power rule for every term. Every term is set up and ready for power rule. There's no adjustments needed. So we add 1 to each of the exponents divided by the new exponent. What's going to happen to the plus c?
Do the CX.
Cx. And then it's going to produce its own constant. So plus c sub 2 or plus k be the process. So I had on my key, I had plus c and k, but you can do plus c sub 1x plus c sub 2. It's up to you. Okay, number 9. Number 9 says find the specific expression. So what that means is we're going to find the general equation first. And then once we get the general equation with the plus c, then we can figure out how the order pair can help us replace that c with a number. So we're still going to take the antiderivative like we normally would. So just take the action that the problem says to do. And then we do power rule. 3x squared minus 4x becomes 3x cubed over 3 minus 4x squared over 2 plus c. So this is my general equation. This is my cleaned up version here. Now that I have my general solution, I'm going to see what additional data the problem has for us to use to help us solve for C. So the order pair, -1, 2 is provided. So we'll take -1, replace -1 in for X, and then plug 2 in for Y. And then our goal is to solve for C, right? So 2 is equal to -1 cubed minus 2 times -1 squared plus C. -1 minus 2 is -3. We solve for C, we get C is equal to 5. Now, when you get C equals 5, don't just stop here. Your goal is to create a specific solution or expression. So go back to your general equation and rewrite your general equation and replace the C with the number that you just found. Okay, let's go to worksheet 2. And let's skip number 1. I think number 1 is just busy work. You're just plugging values in and adding them together. Let's start with number 2. Try number 2 first. Okay, use sigma notation to write the sum. So we know that we got to involve the summation notation here. I equals 1. So we want I equals 1 to produce this term. I equals 2 to produce the second term. I equals 3 to produce the third term. I equals 4 to produce the last term. Let's go ahead and put down the pieces that are not changing. And then we'll do the hard part later. So looks like the 5 is staying consistent, the minus is staying consistent, the square root and the division sign. We just have to fill out what goes in here and what goes in here. So I have to create a pattern where if I plug 1, I get 2, 2, I get 4. If I plug 3 into the expression, I'll get 6, 4, I get 8. What's my rule there? So do that. Next up, if I plug 1 in, I get 1, 2 in, I get 4, 3 in, I get 9, 4, I get 16, I squared. So a couple of patterns. It could be involving multiplying, it could be involving squaring or cubing your variable to an exponent, or it could be involving raising a number to an exponent. So if you explore one of those options, multiplying, raising to a number, or an exponential function, number raised to a variable.
You ever make it to where like I doesn't start at 1?
We can always do problems where I starts at 1. It's just that sometimes it could be easier starting at 0. So it's up to you. You guys have to kind of play around with it, see. But yeah, I would say usually 1 is the easier one to build off of. Now, what's my final I value I'm using? 4. So that goes up top. Okay, let's try number 3. Use 3 left-handed rectangles to approximate the area bounded by our function. First, find the width. How do we? What's my width going to be? E minus A over N. So starting at 3, you're going to keep adding 4/3 until you get to 7. So 3 plus 4/3, same thing as 9/3 plus 4/3, which is 13/3. This one is a little bit easier. It's not asking for midpoint. Midpoint, I would add the 2 numbers, find the average of 2 numbers, and divide by 2 or multiply by 1/2 to get to that midpoint, and then plug into the function. But here, I can just rely on my width and my left height. Use fractions, yeah. Yes. You can use parentheses, or if you do alpha y equals, I think some of the newer calculators should be able to handle that. If you do alpha y equals, that there's an n over d feature there, and then that'll get you that fractional math print. Yeah, so you do alpha y equals, and then a menu will pop up, and there's that first one there, n over d. Yeah.
By parentheses, do you just mean like parentheses 1 divided by 2?
Yeah, yeah. So this will do the same thing. It's just not as pretty.
Yeah.
But it'll do the same thing. I'm sorry. Yeah, like that.
Gotcha.
Oh, but sorry, your final answer, just leave it as decimal. But as you set up though, use fractional values, so it makes it so I can see that you have the exact value. But okay. So now let's build our area in function notation. My area is width times height. So width is 4/3 times, right, what will represent the height of my first rectangle. Left-handed rectangle, so what? F of 3, right? Right, 3 would just be the x value. That doesn't, I still got to plug this into the function to get the height. Plus 4/3 times, what's the left height of the second rectangle?
F of 13.
Yeah. And then third one will be f of 17. Okay, so now it's just a matter of just taking the time to insert these x values into the x of the function, get the y value, and then multiply by 4/3 for each of the width of the area of the rectangles, and then approximate to 3 decimal places. Riemann sums, I think let's skip number 4. I think we should be pretty comfortable with it. The only thing is careful, make sure that you memorize your trapezoid area formula. So with the one half width times height 1 plus height 2. So make sure you memorize your trapezoid area. Okay, let's go to number 5 and do a limit definition. Okay, page 34 is the formula sheet that you can use.
That's what's right.
Yeah, so if you turn to page 34, that's what your formula sheet will look like. Without the trapezoid, I'm not gonna put the, you're gonna have to memorize the trapezoid.
Would we have to memorize this AP exam?
The AP exam is going to present this problem in a different form. I'll show you what that could look like on when we get to AP review. So this knowledge is good for understanding how to do that problem, but I haven't shown that type of problem for you yet. So it basically is not as messy as this, but I'm just showing the kind of background to it that we can use for knowledge to prepare for the AP exam. So that's good. You're not going to have an AP problem where it's going to got to go through all this steps. So, but we do need to have knowledge of this. All right. So what's the width here? Mm-hmm. Okay. F of. A plus width times I, 3 over n. We'll go ahead and just call this F instead. Okay, so we have to get this into an expression form. So take the time to rewrite your function with a set of parentheses, reserving the spot for your new argument. So now this is my width, this is my height. I can now build my area and start working on my height. So the formula says A plus width times I. So my A value is the left endpoint of my subinterval. And then the width is 3 over n, so A plus width times I.
Should you use the one?
No, we want to use the A, not the B. Yeah, so just follow what the formula says. The formula says to use the A value. Okay, so our initial efforts is trying to get this cleaned up so that we can eventually work the width in, but let's just spend our time here because we have to FOIL this out, distribute the 2 through, and then combine with 3, combine like terms, and then all that is, after all that is done, we can work in that 3 over n. Okay, I'm writing out that binomial expression out twice so that I can FOIL. And after I FOIL, then I can worry about distributing the 2 through. And then I can add the 3. And then I can use the width. So work your way from the inside out. Okay, so once I FOIL, I distribute the 2 through. Once I distribute the 2 through, then all the parentheses inside the brackets are gone. I can start looking for common like terms. 3 and 8 is 11. So now I can distribute the 3 over n through. And as I do that, now I can get it down to 3 terms. And once I'm down to 3 terms, I know that each term will have its own summation rule associated with it. So I'm putting a summation in front of each term, and now I'm going to identify the parts that needs to be replaced. So if I push out any coefficient and n variable, then I know what's left over. So this is summation 1, this is summation I, this is summation I squared. Okay, page 34 has your rules. Summation 1, replace with n. Summation I, get n times n plus 1 over 2. Summation I squared is n times n plus 1 times 2n plus 1 over 6. And then within each fraction, you're just trying to figure out what is the highest degree and the number that's associated with it. And that's the only fractional value that will stay. And then you're going to get 3 numbers, add them together. That's your area.
Need to write a limited page now, I'm give it to you, right?
Yeah. Or we just write it once at the top and just draw an arrow to the bottom. Any questions? Yeah.
From the third to last step to the second to last step, you're just plugging them into the
Right here.
yeah, to the identities.
That's right. Yep. This is I'm just replacing this with the identity summation rule in your formula sheet.
Okay.
Everybody go from here to here, knowing how to multiply out just the most important terms to get to where you need.
Just like the formulas right there.
That, yeah. But don't worry about expanding all this out, right? Just take the first term to get to your highest degree and highest term. That should be over.
Did you do all of it? Is it the same thing?
I'm sorry.
If you expand all of it, is it the same?
It's the same thing. It's just that it takes more work and we don't need all the lower degrees. I mean, we're going to have an n squared and n and a constant, but it's just not going to matter. So we just take care of the highest term or the first term. It just saves a little bit of time. There's a bunch more terms, but If it's not part of a higher degree, highest degree, it just drop out, it just goes away.
Those are the terms that like we don't have to memorize, though, right? The formulas.
Right, so if you look on page 34, that's what I'm gonna do. Yeah, just gotta memorize power rule, trig integral rules, and rectangles and trapezoids. Okay, next page. There's one type of problem that did not show up on worksheet 1 that will be on your quiz, and that's gonna be a problem like number 8. So the rule of the direction says just find the general antiderivative. So number 7 and 8 are both power rule. Number 7 is already separated, so that's more straightforward. This one, though, is sitting as a fraction, so we have to separate them first before we do power rule. So let's go ahead and set that up. Show me the integral notation to indicate what action you're about to take. Now, something that I've seen students do is they see a fraction and there's calculus involved. So I see some students try to do quotient rule. Okay, so this is not a quotient rule problem. Quotient rule is for derivatives, not for antiderivatives. Okay, so we're not going to do f prime g minus fg prime all over g squared. That's first semester, right? If I ask you for the derivative of this, then you can do that, but not the integral. Integral, we have to separate. I mean, right now, the only rule that we have is power rule. So we have to get it into that power rule form. Okay, so let's split up into individual fractions. Sorry, over x. And as I do that, I'm also going to try to clean up my radical along the way. Okay, so one more thing that's getting in the way of power rule is there are these variables that are sticking out in the denominator. Okay, so we have to find a way to get those variables to come up to the top. So how do we do that? Again? Not when we're dealing with exponents though. Variables, what do we do? Subtract, yeah. So or just subtract the exponent. So 3 minus 1, 1/2 minus 1, 1/4 minus 1, and that will allow me to merge the two variables into one. And all along the way, we're still not doing anything calculus related. We're still in the cleanup stage. So the first term becomes what? 2x squared. Sorry, minus what? 3x to the
You don't put them in the denominator yet, right?
not yet, yeah, because we're not doing we haven't started power rule yet. We're just getting it ready so that the next step was power rule. Every term is ready for power rule, right? No variable in the denominator, no radicals, no parentheses. Now we can do power rule. Add 1 to the exponent divided by the new exponent. So 2x squared becomes what?
X cubed divided by
X to the negative 1/2 becomes
5x to 1 divided. And x to 1/4 divided by
plus
c.
Okay. This one I can just make it 2/3 in front. I can multiply this by 2/1 and multiply the numerator by 4/1.
So don't change the radicals, we don't want to.
Oh, you mean convert it back to radicals? You don't have to. You can if you want, but you don't have to. Okay, I want to ask you something here. What if I added something to the problem here? What if I made this like an 11x in the denominator? How would that change your setup?
11.
Okay, so F11 will be in the denominator. It'll just be in all the denominators, right? And over here, it'll just be 2 over 11, 5 over 11, 3 over 11. So even as you move the x, the variables, subtract the x, the variables and do all that, any leftover variable, leftover coefficient fractional denominator, it'll just stay in the denominator. So we're not going to move the denominator, it'll just stay and it'll just end up being multiplied with whatever you get from power rule.
Is one equation like that?
So as you deal with the x's, don't move that fractional value. That fractional number is just going to stay there, and it'll just be some coefficient in front of your power rule. Okay, why don't we do number 7? Number 7 is also power rule. See if you can get that set up. Number 7 is a little bit more, a little bit less work than 8 because it's already separated. We just have to make sure that every term is ready for power rule. Yeah, so E is just a what? It's just a number, right? So E to the 4th is still a number. So this whole thing is a number. So just treat this like a constant. The only time that variables will be involved if it was like X, but there's no X here. There's no variable here, right? Everything is here. It's just a constant.
So keep it in the denominator.
Yeah, it's just some number, right? Right. There's no need to move that E to the 4th up. I mean, you can, but we don't have to.
Could there ever be like a log involved or like a?
No, we haven't done no logs yet. We'll do that next unit. So right now it's just power rule and trig. Yeah, there's no need to move that E. This is just some constant. That's just some messy constant. And then, but I did adjust my first term, the radical converted to rational, and then pushed up to the top. Okay, we add 1 to the exponent. Right? Every term is ready for power rule. Now we can apply power rule. As soon as you do power rule, your notation, integral dx book and notation will drop out, and then a plus c will show up. So what happens to x to the negative 1/5? X to the, what's the new exponent? 4/5, right? X to the 4/5 over 4/5. 3x squared becomes
3x cubed.
cubed over 3, and this becomes what?
1 over 3 to the 4.
X. Good. So constant will just become a degree 1.
On the copy over to like the integral sign.
Oh, if you're in the cleanup stage, you're going to keep holding on to your integral. notation, but as soon as you apply power rule, right, adding 1, dividing by that exponent, then it drops out, goes away. Yeah. I added 1 to the exponent, so -1 plus 5/5 would be 4/5. Yeah, so that it needs to start off as x to the -1/5. I gotta move that denominator to the top. Oh, okay.
How'd you get it there?
Right, so square root of 5, fifth root of x, this is the 1 hidden there, and so that's x to the 1/5. I think what you're thinking about is this, right? This one would be x to the 5/2. Okay, can we, few minutes here, can we try number 9? Number 9 is a general solution problem. You're gonna just take the antiderivative twice, plus c sub 1 will show up first time, and plus c sub 2 will show up the second time, or plus c will show up first time and plus k second time. Try number 9.
We do power rule twice.
That's right, power rule twice, yep. Okay, couple of things as we wrap up. Tomorrow's your quiz. Your homework, there's no homework. You guys I just want you to study for your quiz. Worksheet 2, I know we didn't get through every problem in worksheet 2. I'll send out a reminder this afternoon that there's a quiz tomorrow. I'll send out a link to worksheet 2 if you want to check the rest of our answers. If you look in your packet, the next page is worksheet 3. Worksheet 3 is what I'm going to do tomorrow morning for help session. And if you look past that, there is a key to worksheet 3 in your packet. So if you want to use tonight to go through worksheet 3 and see how ready you are, you can do that. But you can also wait for me tomorrow to go over worksheet 3 with you. Make sure you bring your calculator. Make sure you memorize the formulas I need you to memorize. Yeah, if you have any questions tonight, you can feel free to text me through Remind, and I should be able to help answer those questions you still have. Okay, come get the phones. Advisement, second, third, that's just another way, another option instead of speed and or it's a 1 speed 2. It's just another constant. You can do this. Yeah. So do this and do that.
So you have help tomorrow? Good help us tomorrow.
Yeah, I'll send it tomorrow, 7:15, I'll send out a reminder.
Okay.
Well, it's intro to public speaking. I didn't know it was like 7.
Trying to get those postseason game nerves.
Yeah,
Wait, it's not.
hopefully you have a long weekend to celebrate.
Yeah, we hope they win.
Probably similar.
Every time we get to work so hard to get to this point and be losing the first one.
I know.
They're a good team they're playing.
Yeah, for sure.
I still we don't overlook them now.
Yeah, I know. It may be easy to play down to your competition sometimes.
We've been doing that this year. Hopefully they learn from this game. Was that Bill's Mafia show down?
I think I did.
Yeah, that's fine.
Or Bill Belichick's gone, like he left.
Oh.
Bill Belichick left.
Oh, really?
Yeah,
When did that happen?
I think this morning. Like, whoever told me, like, oh. I don't know, Nick Saban retired yesterday.
That's good.
No, they both left and within like a day of each other.
Bill Belichick with the Falcons.
That'd be weird. I'm just happy he's not in Patriot. I'm happy he's not in our division anymore.
I saw like some players are decommitting from Alabama.
Yeah, because that Nick Saban's gone.
That's coach makes a big impact on the program.
I think the coach from Michigan who just won that championship, I think he's going to an NFL team now.
Oh, you think so?
Yeah, people are saying that.
Jim Harbaugh.
Yeah.
You know, when I was growing up, being a Bears fan, we had like
Oh,
he's a really gritty quarterback. I really liked it.
I like Josh Allen.
Yeah, he's my favorite player, right?
Yeah, he's always my favorite player. I've always believed in him, even whenever people even didn't.
Who was your favorite player before he was drafted?
I don't know. It's like back then it was like,
Oh, so you're a bigger fan now than before?
no, I've always been a big fan. It's like I was like an elementary when so I didn't really know the players too much. Probably would have been like LaShawn McCoy or something.
Yeah.
What's when he has some kind of
Yeah, the positional players are usually the ones that get more attention.
the first year I really paid attention was like the year they like it has to be the year they broke the playoff drought. I was able to start playing attention to watching.
Yeah.
So I'm not a bad one, I swear.
Yeah. It's just more fun to root for a team when your team is doing well, right?
Yeah.
It's hard to watch.
I always believe in them. There's been a lot of anxious games for us this year.
Oh, yeah, this year especially.
Let's get us focus on being Steelers and
Okay, guys, study for your quiz. See you tomorrow. Read your calculator.